Hey everyone, welcome to this explainer. So today we are diving into something that literally sounds like it's straight out of a sci-fi movie, but it's actually happening all around us right now. We're talking about home automation. Whether you're in class 8 or you're just super curious about how all those cool smart gadgets actually work, well, you're in the right place. We're going to figure it out together. We'll look at the science, the hardware, and even the code behind smart homes. Let's get into it. All right, let's start with a situation I guarantee we have all been in. Have you ever rushed out of your classroom when the final bell rings? Or, maybe left your bedroom in a huge hurry, only to realize hours later that you left the lights and the ceiling fan running? Yeah, it happens to the best of us. But the reality is, leaving them on wastes a ton of electricity, and it definitely drives up the power bill. But what if the room was smart enough to just turn them off for you? And that brings us to the core of what we're talking about today. Imagine a classroom that has a motion sensor. It basically acts like a digital eye. When it sees that all the students and teachers have left and there's absolutely zero motion in the room, it automatically switches off the lights and fans. That, my friends, is home automation. It's simply when we use technology to operate devices automatically. Imagine entering your room and the light turns on automatically. It makes our lives so much easier, saves us time, and totally conserves energy.
Now, what's really fascinating is that automation isn't actually some brand new futuristic idea. Nature totally invented it first. Just think about your own body. Your heart beats automatically to pump blood, right? You don't have to consciously tell it to do that. Or think about how birds migrate without a GPS. Humans basically just looked at these incredible natural systems and got inspired to build our own versions. We built thermostats that regulate room temperature, just like our bodies sweat to cool us down. And we built motion sensors that react to light, exactly like the pupils in our eyes.
So here is our blueprint for today. We've got our welcome to home automation, then we'll meet the cast of components, understand the input, process, and output cycle, go over staying safe with electronics, actually build a smart light, and finally reflect, share, and innovate. Section 2. The cast of components, meaning the tools of the trade. Okay, so here is the essential hardware every beginner inventor needs. First up is the breadboard. This is a brilliant little board with metal strips inside that lets you plug in wires and test your circuits without needing to permanently solder anything together. It is absolutely perfect for experimenting. Then we have output devices, like an LED, which is a tiny bulb that emits light, and a buzzer that makes a beeping sound. To power it all, we use a standard portable battery, and we connect everything together using these really colorful little cables called jumper wires. But, a circuit isn't smart just because it has power and a light bulb. It needs a brain. Enter the microcontroller. It's basically a mini computer, like the famous Arduino Uno. You can just plug it into your laptop, write a simple program, and give it instructions. It takes in information from the outside world and decides exactly when to turn those LEDs or motors on and off. So how does this microcontroller actually know what's happening outside? Well, through sensors. These act as our electronic sense organs. A PIR motion sensor detects infrared body heat, so if you walk past it, it knows you're there. That's perfect for automatic room lights. A sound sensor detects noise vibrations. You've probably seen those really cool lamps that turn on when you clap your hands. And a temperature sensor measures heat or cold, which is exactly how a smart AC knows when to cool down the room. Moving on to Section 3. Input, process, and output. This is how the magic actually works. The core logic of literally all smart technology is called the automation cycle, and it is always 3 simple steps. Step 1 is input, or sensing. This is when a sensor detects a change, like movement in a room. Step 2 is processing. The sensor sends an electrical signal to the microcontroller. The microcontroller then checks its programming and makes a decision. And finally, step 3 is output. The microcontroller executes an action, like sending power to an LED to light up the room. Input, process, output. It really is that simple, and it applies to almost every single smart device in your home. Oh, and here's a really fun did you know fact. Before you spend any money buying hardware, or if you're just worried about wiring things up incorrectly, you can actually use digital simulation platforms.
Websites like Tinkercad let you drag and drop Arduinos, breadboards, and LEDs right there on your computer screen. You can write your code, hit simulate, and watch your virtual LED light up. It is hands down the absolute best way for beginner inventors to practice safely. Section 4. Staying safe with electronics. The golden rules of the inventor's workshop.
Okay, before we start wiring things up, we have to talk about safety. Always keep your workspace organized so you don't accidentally cross wires and cause short circuits. When you're looking for code online, practice internet safety and don't download files from sketchy or untrusted sites. But the absolute most critical golden rule is this: never connect your homemade electronic circuits directly to the 230-volt AC wall sockets in your house. That is incredibly dangerous. For all of our beginner projects, we are strictly going to use low-voltage DC batteries or the USB power from your computer. Remember, safety first, always. All right, Section 5, build a smart light. It is hands-on project time. Our project today is an automatic light using a sensor, and our goal is wonderfully straightforward. We want to build a system where if movement happens in the room, the light will automatically switch on. Just exactly like that smart classroom we talked about at the very beginning of this explainer. To pull this off, we need to gather up our materials. We're going to use an Arduino Uno as our brain, a PIR motion sensor as our digital eyes, a 5mm LED, and a 220 ohm resistor to make sure our little LED doesn't pop. We'll connect all of this together using a breadboard and some jumper wires. You could even place the final circuit inside a little cardboard house model to make it look incredibly real. And of course, we'll need a computer to program the brain. So let's see how this all comes together. Step 1. Secure the LED, the sensor, and the resistor right onto the breadboard. Step 2. Wire the sensor to an input pin and the LED to an output pin on the Arduino. Step 3. Plug that Arduino into your computer. And step 4. Write a quick little program that basically says, if motion is detected, turn the LED to high and hit upload. Now just wave your hand, the brain processes it, and boom, you've got light. You literally just built a working smart home device. Okay, let's do a quick quiz time to test our inventor logic. If you are looking at your Arduino code and you change the number value next to the word delay, what do you think happens to your physical circuit? Think about it for a second. Well, the answer is it changes the timing of your output. By increasing that delay, you can make the light stay on for 10 seconds or even 10 minutes after you walk away. It's so cool because you have total control over how the machine behaves just by changing a single line of text. Section 6. Reflect, share, and innovate. Taking your ideas out into the world. Let's do a super quick recap of the incredible ground we've covered today. We started by looking at how nature inspired human automation. We learned that vital input-process-output cycle, we demystified microcontrollers, and we literally walked through building a smart light from scratch. I'd say we've officially leveled up our tech skills today, wouldn't you? Before we wrap up, I really want us to pause and reflect on this question. Why do you think automation is required in our modern world? Beyond just being a fun science project, think about the real-world impact. It saves massive amounts of electricity, which is huge for helping the environment. It saves us time by doing repetitive tasks like automatically watering the garden. And super importantly, it can greatly improve safety and comfort, especially for elderly or disabled people who might really rely on automatic lights and voice assistants in their daily lives. Now, if you are taking this knowledge and building a model for a school exhibition, here is how you present like an absolute pro. Hook up your laptop to a projector in the classroom, while your physical model, like that awesome little cardboard smart house, sits on the desk. Use the projector to show the class your circuit diagram on the big screen. Walk them through that input-process-output working principle and confidently explain the real-world benefits of your automation system. Your teachers and your classmates are going to be completely blown away by your presentation. I want to leave you with this one thought. Technology becomes meaningful when we use it to make life easier. Building gadgets is fun, for sure, but building gadgets that solve real problems, that is how we change the world. You now have the foundational tools to look at problems in your own home or classroom and invent smart, automated solutions to fix them. Thank you so much for joining me on this explainer today. I really hope you are leaving feeling inspired and super curious about home automation. Remember our motto, learn, create, and innovate.
Go grab some components, try out Tinkercad, and start experimenting. But hey, right before you go, just look around the room you're in right now. If you could automate just one everyday object to make your life easier, what would it be?